Hello again everyone, and welcome back to Learn Linux TV. In today's video, we're going to check out OpenShift. But hold on a moment, isn't this an OpenStack series? Well, yes, this is episode number 5 of the OpenStack series here on Learn Linux TV, so you are in the right place. But more specifically, what we're going to do is integrate OpenShift within OpenStack. And I think this is going to be a lot of fun because one of the best ways to learn a platform is to actually implement something within the platform. And what could be more fun than OpenShift? OpenShift is awesome. Now, speaking of awesome, you should definitely check out OpenMetal. They're the world's first on-demand private cloud provider. And with their platform, you could easily get set up with an OpenStack implementation of your own. And what could be better than getting set up with OpenStack from a company that adores the technology, they use it internally, they live and breathe OpenStack, they're passionate about it, and their platform is a very quick and easy way to get set up with OpenStack. By visiting the URL that you see on the screen right now, you can get set up with a free trial to try out their platform. And if you're considering implementing OpenStack within your organization, then definitely reach out to OpenMetal because that's what they do. They provide companies with OpenStack. And in fact, they're the entire reason why this series is even possible. They provided the OpenStack implementation that I'm using for the tutorials in this series. And I really appreciate that. So definitely check out the URL that you see on the screen right now to check out OpenMetal, and I would really appreciate that. Anyway, with all of that out of the way, let's go ahead and dive back into OpenStack here for episode number 5, because again, in this episode, we're going to set up OpenShift, which is going to be a ton of fun. So let's get started. Now, if you haven't already worked with OpenShift before, what exactly is it? Well, OpenShift is a container management solution developed by Red Hat. If you've used or have at least seen Kubernetes, then some of the OpenShift side of things might seem familiar as there's overlap between it and OpenShift. But there's definitely some differences between those solutions, especially when you look at how they're built. However, to avoid any confusion, keep in mind that this series is first and foremost an OpenStack series. That means that while you'll see the entire process for building OpenShift, we won't be going over how to use it. Reason being, that would be a tutorial series of and by itself. If that is something that you want to see, leave a comment and you never know, that might happen. Another thing that I'll mention before we get started is that the difficulty level with this particular video is going to increase significantly. Due to that, the potential for errors will also increase significantly. In fact, there's so many components within today's project that it's entirely possible you could do everything right and still run into an issue. And you know what? If you do run into a problem, it's totally fine. It's normal within our career for us to run into some challenges every now and then. And if you do run into an error, instead of getting frustrated, just consider it an opportunity to practice your troubleshooting skills. Regardless of your outcome, even if you only end up watching me build today's solution while taking notes, then you're still 100% successful. Like all of my videos, the goal is to learn. Anyway, with all of that out of the way, if you do want to follow along, then I'll go over what you need in order to follow along during the next section. So in this section, I'm going to go over the requirements for this project. Now these requirements are only for those of you that want to follow along with me as I build the OpenShift cluster that I'll be setting up in this video. And I definitely hope that you'll follow along with me since hands-on labs are a great way to learn. The first requirement for following along is fairly obvious. You'll need an OpenStack implementation. That probably goes without saying, considering the fact that the entire goal of our video today is to build OpenShift on top of OpenStack, but since that is a legitimate requirement, I'm mentioning that right here. Next, you'll need a domain as well. You can use an existing domain if you happen to have one, but without a domain, the complexity around setting up OpenShift increases significantly. Technically, you can work around the domain requirement by adding host names to your etc host file, but that's not a recommended practice, and it's also unreliable. In addition, using etc host for OpenShift is also not supported. But you know what? It's not all that bad because if you register a domain, you could always repurpose that domain for something else later on. Continuing, you'll need a Linux installation, and it doesn't really matter where you're running Linux or what you're running it on. It could be a server, desktop, laptop, virtual machine, or even a container. As long as your Linux installation is using a modern distribution of Linux, then it should work just fine. But why do we need a Linux installation? Well, this particular installation will be used to send cluster build and configuration commands to OpenStack. You could think of this as the administrator's workstation where an individual might manage servers and system resources. And on that Linux installation, I'll be walking you through the process of setting up OpenStack command line tools, and those command line tools will help us interact with OpenStack via the command line. Another requirement is that you'll need to have Python installed within your Linux installation, and it'll need to be version 3.6 or higher. This requirement should be extremely easy because all you should need to do is download and install Python, which I'll also walk you through as well. Finally, you'll need two very important files, an RC file and a YAML file. We'll download these files from OpenStack itself, so obtaining those files is super easy, and I'll walk you through it. But these files are required, so I'm including them on this list. With all the requirements out of the way, we'll start building OpenShift very soon, but before we do that, I need to go over projects in particular because we're going to be building OpenShift within an OpenStack project, so it's going to be important that we know how to create a project, which is exactly what we'll do in the next section. In this particular section, what we're going to do is set up a project. Up until now, we haven't fully explored the concept of projects within OpenStack, but we'll take a closer look right now because this concept is going to be very helpful for this particular project. The reason why we're going to be creating a project is to better organize things. An OpenShift cluster consists of a number of different resources, which include compute instances, security groups, and so on. Due to that, it's a good idea to separate our OpenStack implementation from other things that we might be using OpenStack for. And that's exactly what projects in OpenStack help us achieve. Group resources together so our solutions can be managed more efficiently. So, in summary, projects in OpenStack are basically organizational units. So, let's go through the process of creating a project right now. And to do that, what we'll do is scroll down and choose Identity. And then we'll go to Projects right here. And right here, we have a button to create a new project, so let's click on that. And we'll fill out this form to create the project. What I'll do is name it OpenShift. And then I'll type a description as well. It doesn't really matter what you put here, but I'll go ahead and create the project. I'll do so by clicking this button. And right here, we have our OpenShift project. We also see the description that we typed in. So, congratulations, you've created your very first project within OpenStack. Now, the next thing that I'm going to do is create a dedicated user for this project. So I'll click on Users right here. Again, we were under the Identity section, and then we went to Users. Now we have a list of users here, but we're going to ignore these. We want to create a brand new user, so I'll click Create User right here. And the idea here is that we have a new project, so what we'll do is assign someone to this project in order to manage it. In this case, it's just us. There's no other person, but I like to have my tutorials mirror real-world scenarios whenever I possibly can. So what I'll do is just create a user named Jay for myself. I'll skip the description for now. I'll go ahead and set the password. And then right here for our primary project, what I'll do is drop this down. We'll find the OpenShift project, and here it is. We're selecting that as this user's primary project. And what we'll do right here is make this particular user an admin. So we'll add that user to the admin group. We'll make sure that it's enabled, and then we'll click Create User. And now if I scroll down, you can see right here at the end, my user has indeed been created. So far, so good. Now that we have a new user, what I'm going to do is log out of admin. So I'll click right here and then click Sign Out. Back here on the login screen, let's log in as the user that we've just created. In my case, the username was Jay, so I'll type in the password as well. And as you can see right here, I'm logged in as Jay. We see the name here. And also, check this out. Right here for the project, we're automatically signed into OpenShift. So not only did we log in as the new user, we're also in the appropriate project as well. So now that we have a project and also a new user, what we're going to do in the next section is set up the OpenStack command line tools. Like I mentioned earlier, the command line tools will help us interact with OpenStack via the command line, which is really cool. And then after we do that, we'll start the process of setting up OpenShift. In this section, our goal is to set up the OpenStack command line tools. This will allow us to use the OpenStack CLI, or command line interface. And like I mentioned, the OpenStack CLI will enable us to work with OpenShift from the command line. We could use it to build all kinds of different things without logging into the dashboard. For our purposes, we'll be using the OpenStack CLI to build our OpenShift cluster. This is also where we'll satisfy an earlier requirement that I mentioned. We'll download the OpenStack YAML and RC files, and in fact, let's just knock that out first. So what we're going to do is we're going to drop down project right here, which in my case already is, and underneath that we'll have API access. So I'll click on that. And we don't even have to go far to grab those files. Right here, we have a button that allows us to download the OpenStack RC file, but if we click on that, it's actually a drop-down button, and both of the files that we'll need to download are located right here. So that part could be easier. So what we'll do is just click on the first one, and then we'll click on the second one right here. And as you can see, in my case, both of these have been downloaded. So the requirement for those two files has been met. We could check that box and then move on to the next step. And for that, what I'll do is switch over to a terminal. And the reason for that is because at this point, we're going to start using the Linux installation that I mentioned earlier. Now, if you don't already have a Linux installation of your own, then what you could do is check out the videos I have on this channel. I have videos that will show you how to set up a Linux installation. But anyway, assuming that you already have a Linux installation, we can go ahead and continue. In my case, I'm running Linux on my workstation here, so I don't need to install anything because I already have it. In fact, if I list the storage of my downloads directory, you can see that I have both of those files that we've downloaded from OpenStack, so you'll need to have those as well. We took care of that earlier. And anyway, let's go ahead and get started. The first thing that we're going to do is create a configuration directory for OpenShift. So I'll type mkdir to make a new directory. -p is for parent directory. That'll make sure that the parent directory actually exists. And the directory that we'll create is going to be under the .config directory. And within that directory, what we'll want to do is create an OpenStack directory. Just like that. Now, the next thing we're going to do is find that YAML file that I mentioned earlier. And in my case, that's in the downloads directory. What we'll want to do is move that file. So we'll type mv and then the file name. I'm inside the same directory where that file has been downloaded to. And what I want to do is move that file into the same directory that we've just created. Next, I'll change into that directory. And that's the same directory where the clouds.yaml file is now located. But one thing that we'll definitely want to fix is that the permissions are too wide open, actually. Going over Linux permissions in this video would be out of scope. I have an entire video that goes over that. But long story made short, the permission string that you see on the left-hand side is actually giving read access to everybody. You definitely don't want that. So the command that we'll use to fix that is chmod and then 600. And we'll run that against the clouds.yaml file. And as you can see, the permissions are more restrictive. That's what we want because there's some confidential information inside this file, and we definitely wouldn't want this file to be read by someone who shouldn't have access to it. Now, the next thing that we're going to do is make a quick edit to that file. I'll just use nano in my case. That works quite well. And then what we'll do is find our username right here. And I'll add another line right underneath that. And what we'll do next is add our password to this file. Now, normally you would never want to do this, and there's other ways of storing secrets like passwords that I won't get into in this video because it's out of scope, but it shouldn't matter anyway because this is just an evaluation server. We're just testing things out. This is not going to be used in production. We're just learning. So that's why it's going to be okay for me to type the password right here, but if you are creating a production cluster, then I wouldn't recommend putting your password in clear text. But for the purposes of learning, we'll go ahead and look the other way just this once. So I typed in the password in double quotes, just like that. And that's the only change that we'll make. So I'll save the file and close out. So we've addressed one of the files. But what about the remaining file, that RC file right there? That particular file is going to come in quite handy very shortly. But what I'll do to keep things simple is I'll just move that file to the root of the home directory. Currently it's in the downloads directory, so let's go ahead and move that out of there. Then I'll type a tilde for the home directory. And as you can see right here, we have the file. So the next thing that we're going to do is set up Python. It's possible that you might already have Python on your system, but we want to make sure that specifically we're using Python 3. If we just type Python on the command line, well, it might work or it might not. In my case, well, I don't even have that installed. So to install Python, what we could do is run sudo apt install, and this command will work on Debian and Ubuntu installations. We're going to install Python 3 -venv, and we'll install those two packages right there. That's going to require some dependencies, but that's fine. That's all expected. I'll just press enter to accept the default here and get these packages installed. Should happen very quickly. And it's done. Super simple. So now the requirement for Python has been met. So now we have Python support within our Linux installation. We'll use this to create a virtual environment, which is a concept that's often used while programming with Python, but a full Python walkthrough is beyond the scope of this video. But if you do want to learn more, I have an entire series on the channel that teaches Python, so if Python programming is something that interests you, that might be a series that you might want to check out. And because I have that series available, I won't go into too much detail here about Python, but we actually don't need to dive all that deep into Python anyway. We're going to use it to install some packages that we'll need, but the Python requirement is fairly light, at least in our case for this project. But anyway, we're going to create a virtual environment, and essentially what that is a working environment that's separate from the rest of our system. Anything done inside the virtual environment will not make permanent changes to the operating system itself. And that's why it's so popular, because it's a way to isolate your programming without impacting the rest of the server. Anyway, to create that virtual environment, here's what I'll do. I'll run Python 3-m. We want to create a virtual environment, and we'll just give it the same name. And if I list the storage, you can see that we have a new directory there, venv, again, short for virtual environment. So we have successfully created a Python virtual environment. But simply having this directory exist on our system isn't enough to have it add value to what we're trying to achieve today. A virtual environment in Python, if you haven't worked with that before, needs to be activated. To do that, well, here's what we'll do. We'll type source, and then the path to the venv directory. It's right in my home directory. Underneath that, we have a subdirectory of bin, and within that directory, we have activate. By running this command right here, we're going to be activating the virtual environment. And as you can see, the command line has actually changed. On the left-hand side of the prompt, it shows venv. And that's how we know that we're using the virtual environment. The next thing that we're going to do is run the following command. We're going to run pip, and then install --upgrade, and then pip. Now, if you haven't heard of pip before, that's a package manager for Python. It's quite popular, actually. So we're using the pip command to install a Python package. And since we're doing this within the virtual environment, the package that we're about to install will not be accessible from the rest of the operating system. Again, we're running within a Python virtual environment, so Python packages that we install right here will not be installed system-wide. They'll be restricted to this particular virtual environment. So if you ever work with the OpenStack command line tools in the future, just keep in mind you'll have to activate this first before those tools will work. Now, in particular, I'm using the --upgrade option. Pip is something that comes along for the ride when you set up a virtual environment, but it's not up to date. So what this command is going to do is make sure that the pip package manager for Python is up to date. So I'll press enter. I ran this earlier on this system, so I already had this requirement met. But if your version of pip in your virtual environment isn't the latest version, then this command will go ahead and upgrade that. Next, what we'll do is run pip yet again, and then install. And the package that we'll install in particular is the Python-OpenStack client package. And this is what's going to give us access to the command line tools for OpenStack. So it's definitely important. And as you can see, it's installing. And we can ignore those deprecation warnings. It's not uncommon to see that when we're working with tools like this. It's not going to impact us at all, so we'll just disregard that. And at this point, we should have everything that we need to configure the OpenStack tools to work with our OpenStack implementation. And to get started with that, what we'll do is type source. And if you recall, we have an RC file, but we have yet to use it. We moved it to our home directory, but after that, we've done nothing with it. Well, we're going to use it right now. And we'll source that file, OpenShift-openrc.sh in my case, and source is going to read the contents of that sh file, and that'll configure our environment to be able to work with OpenStack. So I'll press enter, and it's going to ask me for the password for the user. It already knows that the user is Jay because we downloaded the RC file as Jay, and it pre-configured that for us, but what it didn't do is add the password to the OpenStack RC file. I'll just go ahead and type that in right now. And there we go. Now what we're going to do first is change the quotas for CPU and memory within our OpenStack implementation. As you probably know, a quota is a limit, but we don't want to limit CPU and RAM, and the idea behind that is OpenShift can manage its own resources, so we don't really need any quotas within OpenStack. If we want to set up OpenShift quotas, we can do that within OpenShift, but to remove those quotas, here's what we'll do. We're going to run OpenStack, and then quota, then we'll type set -- cores, and this will allow us to set the quota for CPU cores. And if we set the quota to -1, that disables a quota. And we need to target this against a project. So we'll configure the OpenShift project. And the reason for this is because we don't want to remove quotas from our entire OpenStack implementation. If we run it against this project, then this only applies to this project. That way, if we need to utilize quotas within OpenStack for other projects, we can still do that. And there we go. The next thing we're going to do is do, well, the same exact thing, but this time we're going to be removing a different limitation, this limitation being around memory. We want to disable quotas around memory as well, and that's what this command does. Now the next thing that we're going to do is set up a key pair for SSH. We've done this earlier in the series, but we're going to do it a bit differently this time around. We want to create an SSH key that's specific to our project today, so we're going to create a brand new key. Creating an SSH key, even if we have a virtual environment active, will still create the SSH key on our system the same way as it would otherwise. The virtual environment only applies to Python-related activities, so the key that we're going to be creating is going to be on the actual system. So I wanted to make that clear that when I mentioned that virtual environments keep things separate, that applies to Python-related activities, not to other things like creating an SSH key. Anyway, to create a new SSH key, we'll type SSH keygen -t, and that'll help us specify a particular type of key. And the particular type of key that we want to use right here is the ED25519 key. And I'm going to go through this part a little bit quickly because I have an entire video that goes over this in more detail. We'll keep this simple. For -f, we're just choosing where we want this key to be located. And we'll create it in our home directory underneath the .ssh directory. And we'll give it a name of ID_OKD. And that should be good enough. So I'll press enter. And that's it. We've created a key. Now, in order to help facilitate us using this key, it's probably a good idea to spin up an SSH agent. This is something that should be built in if you have SSH available. So you should be able to run this command. We'll type eval, and then in double quotes, we're going to create a subshell. And within that subshell, we're going to run the ssh-agent command, along with the option of -s. Now to keep this simple, what we're doing is we're spinning up an SSH agent that's going to run in the background. Now if we close this particular terminal window, then our SSH agent will also close as well. But as long as we have this terminal window open, then this will make it easier for us to facilitate using a key like this. Again, I have other videos that go more into detail about this very subject, but I wanted to give you that quick overview. So press enter. We get a process ID here, in my case, 24173. That's a process ID on the Linux system itself, which means that it's running. And then what we'll do is add the SSH key that we've just created to this SSH agent. And to do that, we'll type SSH add, which was in our home directory underneath .ssh. And we called it ID_OKD. So we'll add that to our keychain here. And that's it. Now this next example is going to be pretty interesting because what you're going to see is the process of creating a resource within OpenStack from the command line. Specifically, what we're going to do is create not one, but two floating IP addresses. We created a floating IP earlier in the series, but again, what we're going to do right now is do the same thing from the command line, and we're going to need two floating IPs. So here's how we're going to go about creating these IPs. So we'll type OpenStack, we'll type floating IP, we want to create one, we also want to provide a description, and what I'll do is type within the description API, OKD, and then test cluster. It doesn't really matter what you give it for a description, but I recommend you at least include API here because the distinction between API and apps, as you'll understand here very shortly, is important. Anyway, after that, we want to attach this to our external network. We need to be able to route to the public internet to download things and connect to the instance. So I'll press enter. And check this out. We have a lot of output here, but as you can see, we have a floating IP address right here. What I suggest you do is copy that, or at least write it down. Make sure to mention API next to this IP address. The IP address will be different for you, but the purpose is going to be the same. This IP address is for the API. Now, I mentioned that we're going to need a second floating IP, so let's create that right now. In fact, what I'll do is just recall the previous command that we used. Most of it's going to be the same. In fact, we only need to change just one thing. We'll just make sure that we reference apps within the description. And that just helps us differentiate the purpose between the two IPs. So we have another IP right here. So we'll copy that. And I recommend that you write that down and put the word apps next to it. It'll come in handy very shortly. And now we have our floating IPs. Now for a little bit of fun, what we could do is go back to the dashboard, the web dashboard for OpenStack. And if we go to network and then floating IPs, we have the IPs right here. We have the description and we have the IP addresses. We didn't even have to create an IP address within the dashboard right here within Horizon. We were able to do that from the command line. And even if I wasn't logged in, I still would have been able to do that. And that's pretty cool. Now that we have our two floating IP addresses, we can set up DNS records. This process will be different depending on where you've registered your domain. But basically, when you register a domain name, you'll typically get access to something called a DNS manager. Maybe it might be called something like DNS console, DNS settings, something like that. You'll find that within your registrar's control panel, and within there, you can add the DNS records for our floating IP addresses. But before we go ahead and add the DNS records, I want to break them down so that way you understand how they're structured. Now, the first thing we'll need is what OpenShift refers to as the base domain. And that's easy. That's the domain name. Whatever domain name you've registered for this project, that's what your base domain is. As for me, the domain that I'll be using going forward will be learnlinux.cloud, so that's going to be my base domain. On your end, anytime you see learnlinux.cloud, you'll want to change that to whatever your domain happens to be. The next part of the name is going to be the name of the OpenShift cluster itself. I'm going to name mine OKD. That's going to be my cluster name. If you're curious where I came up with OKD, that's a common acronym when it comes to OpenShift. OpenShift itself is a downstream project of OKD. OKD stands for Origin Key Distribution, so that's a bit of trivia if you didn't already know. Anyway, now that we know what our base domain is and what our cluster name is going to be, we could put together the DNS entries that we'll need to add. And here I've logged into the DNS settings for my domain. I'm going to add the domain on my side. Now again, this will probably look different for you, but the idea here is that we need to add an A record. So we'll look for a button that gives us access to create an A record, and in my case, it's right here. We'll go ahead and add that. And right here, we'll add the first domain. Now, depending on how your registrar is set up, most likely you won't need to type the entire thing. So for the first one, we'll type api.okd, and that should be it. The base domain doesn't need to be typed right here because that's already assumed. I'm logged into my domain manager. I've chosen that domain. So the console here knows that I want to work with learnlinux.cloud in my case. So that's why I don't have to type out the entire thing. Anyway, what we'll do here is paste in the IP address that we've designated for API. So I'll paste that in right here. For the time to live, I'm going to set that to just 2 minutes in my case. That'll make sure that my DNS cache for this particular domain is only honored for 2 minutes. And then my browser, command line, or whatever I'm using will need to look it up again to make sure that it has the appropriate IP address. When I'm evaluating things, I like to set the time to live to a very low number. I wouldn't do this in production. But when it comes to testing, maybe we might regenerate the IPs and we wouldn't want to wait a long time for that to, drop off of our account. So I'll just set it at 2 minutes. And then if, this becomes production, we could always increase the time to live to something higher. But for this purpose, I think 2 minutes is fine. So I'll click Save. And we have our first domain right here. We're going to go ahead and add another one. And then for the host name here, we'll type API and then -int.okd. The IP address here is going to be the API IP address again, just like that. And just like last time, I'll set the time to live to 2 minutes. Let's go ahead and save it. Now we have the first 2 DNS records set up right here, so we will add one more. And for the host name here, we're going to type * dot and then apps and then .okd. And as you could probably guess, we need to paste in the apps IP address here. So I'll do that. I'll choose the same TTL. We'll save it. And we have the 3 domains right here. Just take a moment to make sure that you've typed in the appropriate IP addresses here. And then at this point, everything is out of our control. DNS takes some time to propagate, so we need to give this some time to do so. We can't move on to the next step until the DNS entry has been propagated. But if you're curious how we do that, what we could do is go to the command line right here. We could type nslookup, and then we could type in one of the domains. So for example, api-int.okd, and then our base domain. And I'll press enter, and it's telling me that it can't find that domain. That's expected. I literally just added those 3 DNS entries, so I wouldn't expect it to have propagated already. So what I'll do is just give this some time, maybe at least 15 minutes, and then I'll come back. I'll try it again. And when it's propagated, we'll go ahead and continue. I recommend that you do the same, and whenever you run this command and it shows the appropriate IP address, then that means it's propagated. Anyway, I'll be right back. I'll give it some time to propagate, and then we'll go ahead and continue. So I think enough time has passed. So what I'll do is try this again. Let's see what happens. And take a look at that. You can see the first attempt at the top there. That was before DNS propagated. And then I ran the same command again. And as you can see here, for this particular domain, it shows the proper IP. That's the API IP address. So far so good. I'm not going to bother and check the other ones. I created them all at the same time. They should be propagated as well. Feel free to check the other domains on your end if you'd like. But let's go ahead and continue and move on to the next step. So now what we're going to do is actually finally install OpenShift. We had quite a bit of prep work to do that we're now finished with, and now the only thing that's left is actually installing OpenShift. So let's do it. The first thing that we'll need to do is create an installation directory that will hold the installation files for OpenShift. So I'll type mkdir and then -p, just in case the parent directory doesn't exist. Inside my home directory, we'll make sure that we have an okd directory. So now I'm inside that directory right now. Now the next command that I'm going to give you is definitely going to be the longest command that we've entered during this video so far, if not the entire series. So what I recommend you do is just take your time with this one. That way we can minimize the risk of typos or something like that. But I'll paste it in. And here it is. The curl command allows us to retrieve information from the internet. -O is allowing us to set a name of an output file. For that, I chose OpenShift-install-linux.tar.gz. And for the location, that's the -L option. For that, I typed in a URL, as you can see. This URL is for the OpenShift installer. And you can see that I wasn't joking when I said this command was quite long. And what we'll do is press enter. And that's done. And as you can see right here, we have the OpenShift installer. And that's exactly what we'll use to facilitate the remainder of the installation. If you've received any errors on your side, then what I recommend is you just double check everything that you've typed in. So much as one character off is going to make the entire download process fail. And then once you have the installation file, we can go ahead and continue. And the next step is going to be to extract that file right there. If you haven't seen a tar.gz file before, .gz stands for gzip, and it's not unlike a zip file in the traditional sense. .tar means it's also a tar file, so it's a compressed tar file. That's what this is. Anyway, we can extract it by running tar and then xvf. We want to extract this particular file, and then we'll type the name of the file. So we can just start typing OpenShift, press tab, should autocomplete, and I'll press enter. And it looks like it has indeed extracted the OpenShift install file. We see that there on the left. That's the install program that we'll be using. So far, so good. Now, the next thing we're going to do is download some manifests that we'll be using to facilitate this process. We should probably store those in their own directory. So what I'll do is create a new directory underneath the OKD directory that I'm already inside of. And I'll call it install-directory. So at this point, we have the install directory that we've created. We have the OpenShift install program that we've downloaded. We can remove the tar.gz file if we don't think we're going to need it. It'll probably make sense to hang on to that just in case we need that in the future. It's up to you. But for our purposes, we do have everything that we need at this point. So now that we've created the install directory, let's go ahead and run the install program. Now again, we have OpenShift install right there. That's the program that we'll be running. And to do that, we'll type :/OpenShift-install -dir. And we'll reference the OKD directory that's within our home directory, the same directory that I'm inside of right now. We just want to make sure that we're targeting the correct directory. And we'll reference the full path to the install directory that we've created. And what we'll do in particular is create the manifest that we'll need for this project. So let's run the command. And what the manifest actually is going to be a configuration file that's going to help us choose some of the options that we want to configure for the installation. And what we'll do is answer each of the questions. So for this one, it's just asking us which SSH key we would like to use. In my case, I created the ID_OKD SSH key, which is in the middle of the list here. So I'll select that and press enter. And next, it's wanting to know what kind of cloud we're working with. Yes, we're setting up OpenShift, but we could set up OpenShift within other clouds. For example, you can see we have a number of those here, but since we're working with OpenStack, we'll go ahead and go all the way down here, and we'll choose OpenStack from the list. Now for the network, we're going to choose the only option that we have right here. And this is going to be the network through which your instances can access the public internet. In my case, that is the external network, so I'll choose that. And now it wants to know which of these floating IP addresses are associated with the API. And in my case, it's this one right here. So just check the IP that you wrote down and then choose the appropriate IP address. And then next, we're going to choose a flavor name. So as you can see right here, if we scroll down, we have a bunch of flavors. These are the same flavors that we have in OpenStack itself. That's where it's pulling this from. And for this, there's some special considerations to keep in mind when we choose the flavor. The flavor that we choose will need to have a minimum of 16 gigabytes of RAM, at least 4 CPU cores, and also a minimum of 100 gigabytes when it comes to available storage space. You can check the list of flavors within your OpenStack installation to determine which of these you should go along with. In my case, the gp1.xlarge flavor meets all of those requirements, so that's the one that I'll choose. Next, we'll type the base domain, and that's going to be the domain name that you've registered or associated for this project. And I've typed in mine. For the cluster name, we'll type that in right here. In my case, it's OKD. Now for the pull secret, we have to be careful what we enter in right here. I'm going to provide you with what you should enter in for this prompt, but we want to make sure that we type it exactly as I give it to you, otherwise this will fail. And I have that saved in a text editor right behind this terminal window actually. And there it is. So I'll zoom in to this pull secret right here, and what I want you to do is type in exactly what I have here in this window. This is actually a fake pull secret, but it's a specific one that will work. It's not for production purposes. And if you're curious what the pull secret is used for, it's used for the process of pulling container images from private registries. Now, if you have a real pull secret, you can go ahead and put that in right here. But if you don't have one, which will probably be most of you, then what I recommend is you enter in the one that I've provided right here. And what that'll do is allow the process to continue. Just make sure that you have it typed in exactly as I have it here. In my case, I'll just copy this. And then I'll paste it in. So in my case, when I pasted in the pull secret, it's hidden that behind asterisks, as you can see right here. But as long as we type in the correct pull secret, we should be good to go. And as you can see here, the manifests were created. And that's awesome. However, those aren't the only files that we'll need to create. So to create the installation config file, what we'll do is run that installer yet again. And then we'll use the create keyword. We want to create the install config, and then --dir for directory. And what we'll want to do is point it to the exact same directory. That was tilde, short for the home directory, and then the OKD directory, and then the install directory. That's where we want to create the install config. So I'll press enter. Let's see what happens. Well, that was simple. Now the next thing that we'll do is create a security group. Now we've done that before earlier in the series, but this time why don't we use the OpenStack CLI client to create the security group? And this is a good example of how the OpenStack CLI can help us, because with it, we could build OpenStack components without even having to open up a web browser. So what I'll do is create the security group right now. And to do that, I'll type OpenStack, and then security group. We want to create one, and what I want to name it is OKD-deploy. Now this doesn't look all that great because what I've done is I've increased the font size as I do in all of my videos to make sure that you guys are able to read everything. But unfortunately, in this case, it's caused the text to wrap all over the screen. But what we're looking for is the ID for the security group that we've just created. So we'll want to scroll through here and try to find it. And actually, here it is. We're going to copy this ID, which I've done. And what I suggest you do is just open up a text editor. If you don't already have one open, since I already have a text editor open here, I'll just paste it right there. Now back here in the terminal, what we're going to do is add a rule to that security group. And to do that, we'll type OpenStack, and then security group. We want to work with rules. We want to create a new rule. And for the protocol, we'll set that to TCP. We want to add a remote IP address. And then the IP address that we'll type right here is, well, your IP address, your public IP address. And this is something that you should be able to fetch online. If you don't already have a chosen website to pull your public IP from, if you don't already know what your public IP happens to be, what we could do is switch over to a web browser. And then in a new tab, what we could do is go to the website icanhasip.com, and that website will tell you what your public IP happens to be. And it's already detected mine, so I will copy that. We'll paste it right here into the command. Right after the IP address, we'll type /32. We want to restrict this rule to this IP address and no other IP address. For the description, in double quotes, what we'll do is add a description. I think that's good enough. Anyway, I'll press enter. And it's added the rule. That's pretty cool. So now that we've generated the install config, we're almost ready to go, but we need to make a few changes to that file because it's missing two specific options that are needed to make the file complete. So I'm currently inside the OKD directory, and underneath that we have the install directory, and inside there we have the install config. When we generated the install config, this is where it saved it to. So what we're going to do is edit that file. So that's yet another file that we'll need to edit, and I'll use nano in my case to edit that file. And again, the file is inside the install directory, and it's called install-config.yaml. And here's the file. So what we're going to do, like I mentioned, is add two additional fields within this file. For the first one, we're looking for control plane. And in fact, I see it right here. And inside this section, we're going to add the first of the new options. Specifically, we're going to find the platform line that's underneath control plane. And then we'll delete the brackets right here. And then I'll add a new line. And if you haven't already noticed, the tabs in this file are 2 spaces each. So what we'll do is press space a couple of times, and then 2 more spaces to tab over one more time. And what we're going to do is add the word OpenStack right here. And then we're going to tab 3 times, so 6 spaces in this case. And we're going to add the new option, which is additional security group IDs. And pay special attention to the letters that are capital. And then we'll type colon, 2 brackets. Inside the brackets, we'll add a pair of double quotes. Inside the double quotes, what we'll do is paste in the ID number for the security group. And if you recall, that's what we copied down earlier when we created the security group. And here's the ID for mine right here. So we're going to grab that from wherever you saved it, and we'll paste it in between these 2 double quotes. Just like that. So the first option is all set. Now the next thing we're going to do is look for the word platform again. However, the word platform is listed a bunch of times in this file, but the one that we're looking for is going to be aligned all the way to the left. And there it is. So we'll add the second option underneath platform. And what we'll do is look for API floating IP, and here it is. At the end of that line, we'll just add another line. And we're not going to tab over any more than this. We want to line this up with the option before it, the option that we're going to be adding. And that option will be ingress floating IP. And what we'll do is paste in the IP address that we designated for that particular use case. The first one is right here, so it's the only other IP anyway, so it should be pretty easy. And I'll paste it in. And there we go. And that's the final change that we needed to make to this file. So let's save it and close out. The next thing that we're going to do is make a backup copy of this file. And the reason why we're backing this up is because when we run the installer, the install config will be loaded and the file will be moved. So we should create a backup copy just in case we need to rerun the command. Hopefully everything works on the first attempt, but just in case, it's good to have a backup. So we'll type CP for copy. And we'll copy the same file we were already working with. I'll just go ahead and copy it to my home directory. It doesn't matter where you copy it to, it just needs to be available if we need it. Now that the install config has been created, modified, and backed up, we're ready to install OpenShift now. And this is exciting because we've done a lot of prep work, and this is where we actually get the process started. Now, if you run into errors and the process fails, don't worry about it. OpenShift, along with OpenStack, are very complicated and complex pieces of software. In fact, these applications are huge. There's a lot of moving parts. So if you do get an error, don't worry about it. That's part of the fun. When we see an error, we try to solve it. But anyway, what I'll do now is run the actual install command, and hopefully, if everything works fine, then that command will build our OpenShift cluster, which is going to be awesome. So here in my OKD directory, I'll run the OpenShift install command. And what I want to use it for is to create a cluster. We'll set the directory, the same directory that we've been working with. So I'll type ~/okd, and I'm already in that directory, but I like to be explicit whenever I can. Anyway, underneath that directory, we have the install directory. And finally, we'll add the option --log-level. We'll set that to info mode. And moment of truth. Let's see what happens. I'll press enter. And it's running. Now this process can take a very long time, probably around 30 minutes, give or take. So it varies, but it is going to take a while. So what I recommend that you do is pause the video, maybe stretch your legs, go outside, grab a cup of coffee or whatever refreshment you feel is appropriate. And after around 30 minutes passes, then I'll meet you back here and we can resume the video. So it looks like the process is completely finished on my end. As you can see near the bottom of the terminal window here, it took just under 39 minutes for this process to finish. So, like I said, it does absolutely take a while. But it appears to be finished, so how about we actually attempt to log in to OpenShift? So what I'll do is copy this URL right here, and then we'll go back to the web browser, and in a new tab, let's paste in that URL and see what happens. We could safely ignore this message right here. It's giving us this message to let us know that this installation is using a self-signed certificate, which is expected unless you have a certificate that you'd like to provide to this installation, but that's beyond the scope. We're just evaluating OpenStack and OpenShift at this point. But anyway, I'll just click Advanced right here and we'll continue. And check it out. We have a login screen right here for OpenShift. Now back in our terminal, it gave us the password. So the username is going to be kubeadmin. You see that right here. I'll copy this password. And let's try to log in. And check it out. We have OpenShift running on OpenStack in all of its glory. We can see the OpenShift interface right here. And if we go back to OpenStack, and then we go to, I don't know, let's try compute instances, for example. And, well, check this out. There's 6 compute instances right here. And I didn't even create a single instance during the course of this entire video. And they certainly weren't here when I started recording. Well, when we ran the OpenShift installer, it created these instances to satisfy the requirements of OpenShift. OpenShift is going to be made up of more than one instance. We have controllers, nodes, and other resources that were created as part of the installation. But I just wanted to show you this because even though we didn't create the OpenShift installation from within OpenStack itself, we used the command line for that. When you use the command line with the API, then any changes you make are being made directly to OpenStack itself, as you can see right here. And as a result of all of our hard work during this video, we have an OpenShift installation that's ready to go. Now, if you ended up receiving an error message rather than a successful installation message, then you know what? It's fine. This is something that we run into all the time as Linux administrators. If something doesn't go according to plan, well, that's an opportunity for research and learning even more. There's also forums on learnlinux.tv if you want to ask in that particular community forum if you run into a problem, but hopefully the process has worked out for you and you have your OpenShift installation ready to go. A solution in particular that we could use to run container workloads. OpenShift is amazing and I think you're going to love it. What I recommend you do is just explore the user interface a bit. We could click on workloads, you can go to pods, and right here we have some default pods. Pods are what containers run inside of when it comes to container orchestration solutions. And we could even create a new pod. We could customize anything we want because we have an entire OpenShift solution at our disposal. Now, as far as how you run containers and things like that, that's better suited for an entire walkthrough on OpenShift itself. And it's not all that unlike Kubernetes, which I do have tutorials for on this channel. But I'll leave it up to you to explore OpenShift because this series is very specific to OpenStack, That's our focus. But I wanted to walk you through the setup of OpenShift because it's an awesome solution in and of itself, and it's worth exploring. However, with this set up, we're all set when it comes to our purpose for today's video. So, as you can see, OpenShift is awesome, and it fits in well with OpenStack. OpenStack is awesome, you guys are awesome, and OpenMetal is awesome for sponsoring this series. There's a lot of awesome around OpenStack, and I'm loving it. But you know what? We're not done yet. There's still another episode left in this series, and I can't wait to produce this one for you guys because it's all about automation, which is another of my favorite topics. So definitely subscribe to Learn Linux TV for the latest in Linux if you haven't already done so. That way you can get notified when the next episode is available if it isn't already. Anyway, thanks again for watching. I really appreciate it, and I'll see you in the next episode.